Curious how mobile apps securely connect to back-end services? Explore the power of APIs and authentication. Discover the key to safe data exchange, REST APIs, authentication tokens, and error handling best practices. Picture this: a seamless connection between your app and the backend. No room for errors. Ready to dive in? Let's crack the code on secure app connections. From REST APIs to authentication tokens, we've got you covered. Stay tuned for a smooth ride into the world of mobile app security. Remember, connect with confidence for a seamless user experience. Ever wondered how mobile apps talk to servers? Today, we delve into the world of REST APIs, unraveling the language of client-server communication. Then, we tackle the fortress of security with authentication tokens, safeguarding your API calls. Next, we explore the realm of refresh tokens, ensuring seamless, lasting user interactions. Journey with us to the realm of secure storage, where we shield sensitive data on devices. And when hiccups occur, master the art of error handling, gracefully navigating through challenges. By the end, you'll craft robust connections between mobile apps and servers. Remember, building trust and security is key in this digital landscape. Ever wondered how your mobile app communicates with a server? Enter REST APIs. REST, or Representational State Transfer, serves as the language bridging these interactions. Each HTTP method, GET, POST, PUT, DELETE, fulfills a specific purpose: retrieving, sending, updating, or removing data. Crucially, REST APIs are stateless, encapsulating all request details without relying on past interactions. Picture it as a streamlined, self-sufficient system. Streamlining data exchange, REST APIs ensure seamless communication. When your mobile app needs data, it sends an HTTP request to the server. The server processes the request, interacts with the database if needed, and sends back a response. This response includes a status code, like 200 for success or 404 for not found, and the requested data, usually in JSON format. The client context, server response, transport, and client request all play vital roles in this client-server communication dance. The server diligently processes requests, queries databases, and forms responses, while the network securely sends requests over HTTPS to API endpoints. The client, meanwhile, crafts HTTP GET requests with headers to fetch the necessary data. This interconnected flow ensures smooth data retrieval and exchange between client and server, powering the functionality of your mobile app. Remember, effective client-server communication hinges on clear requests, efficient processing, and timely responses. Ever wondered how user profiles are fetched in a real-world app scenario? Let's dive into the process. The app initiates a request by querying /API/user/123 to the server. In response, the server efficiently retrieves Sarah Chen's details from the database, formulates the data, and sends it back with a 200 OK status. The JSON payload contains Sarah's name, email, and profile photo link. This information seamlessly populates the app, displaying Sarah's profile on screen. Streamlining the interaction between app and server, this example highlights the smooth flow of user data retrieval. Why do we need authentication? To safeguard user data, thwart unauthorized access to personal information, and confirm identities. It's the gatekeeper that ensures only the right people get in, preventing imposters and bots. With authentication, access is controlled, allowing admins to wield power while maintaining user privacy. Imagine a world without it: chaos and breaches. Authentication, your API's shield and protector. End takeaway: authentication is the crucial gatekeeper that secures your data and keeps your API safe. Ever wondered what authentication tokens really are? Think of them as your digital ticket after logging in. Once you enter your credentials, the server hands you a unique token to include with every API request, verifying your identity securely. These tokens, comprised of lengthy, random characters, ensure a safer alternative to transmitting your password repeatedly. Take a look at a real token, EYJHBJIUZI1NI is in R5CCI66BCJ9.EYJ1C2VSW CHIOJEY MyWeAWF0IJOXNJC40TG3 New Jersey AWFQ.K9MXV_HQ7P2SY8NF3RT6WL. Embedded within this token is encoded user information and creation timestamp. Remember, authentication tokens are your key to secure digital interactions. Ever wonder what happens behind the scenes when you log into an app? Let's dive into the login flow. User enters credentials, username and password securely input. A post request is sent to /auth/login, transmitting the data to the server. The server then validates by checking the password against the database. Tokens are generated and access token and refresh token are created for authentication. Finally, the app securely stores these tokens on the device for future use. Each step plays a crucial role in ensuring a smooth and secure login process. With your token in the authorization header, each API request securely identifies you without exposing your password. The word bearer precedes your token in the header. Upon a valid token, the server responds with the requested data. For instance, a GET request to /API/messages provides the JSON response with message details. However, an expired or invalid token triggers a 401 unauthorized error. Ensure your token remains valid for seamless data access. Ever wondered how tokens work behind the scenes? Let's break it down. Access tokens are like day passes, short-lived and used for each API request, packed with user permissions and swiftly expiring for security. On the other hand, refresh tokens are more like your employee ID, lasting days or weeks, solely used to fetch new access tokens, securely stored, and revocable by the server. So, next time you access a building, think of the access token as your day pass and the refresh token as your trusty employee ID for renewals. Keep this distinction in mind for a seamless and secure user experience. Ever wondered why we use two different tokens? It's all about better security. If an access token is stolen, no worries, it expires quickly, limiting potential damage. And for users, enjoy a seamless experience as the app refreshes the access token in the background, so no need to log in constantly. Plus, servers have control to immediately revoke refresh tokens if anything suspicious comes up, securing devices instantly. This two-token system strikes a perfect balance between security and convenience, a must-have industry standard for mobile apps. Ever wonder how your app seamlessly stays connected, never missing a beat? Picture this: your access token expires, triggering a 401 unauthorized response from the server. But fear not, for the token refresh flow is in motion. Without skipping a beat, your app swiftly dispatches the refresh token to the /auth/refresh endpoint. A new access token is swiftly issued, paving the way for a successful retry of the original request. All this happens behind the scenes, seamlessly and effortlessly. In a well-designed app, the user remains blissfully unaware of the silent ballet of tokens. Effortless token refresh, keeping your app in the game without missing a step. Where should you store tokens to keep them secure? Insecure storage methods like plain text files, shared preferences, local storage, or in your app's code make it easy for attackers to steal tokens and impersonate users. Opt for secure storage options such as iOS Keychain, Android Key Store, encrypted databases, or secure token managers. These utilize hardware-backed encryption to safeguard tokens even if the device is compromised. Remember, protecting tokens is crucial for preventing unauthorized access and maintaining user trust. How can we ensure secure storage of sensitive tokens in our applications? Firstly, never log tokens to the console or files, treat them with the same sensitivity as passwords. Utilize platform APIs such as iOS Keychain and Android Key Store, purpose-built for secure secret storage. Remember to encrypt tokens before storing them in a database, never in plain text. And, crucially, clear all tokens immediately upon user logout, don't leave them lingering on the device. Protecting sensitive data demands diligence, and these best practices are key. Encountering errors in APIs can be frustrating. A 401 error signals a missing, expired, or invalid token. Simply refresh or prompt the user to log in again. Moving on, a 403 error indicates authentication without the necessary permission. Offer clarity in your response. When facing a 404 error, the requested resource is nowhere to be found, perhaps it's been deleted or there's a URL issue. If a 500 error pops up, it's a server hiccup, wait a bit or provide a friendly error message. Lastly, network errors could mean no connection or timeouts. Inform users they're offline and give them a retry option. Remember, errors happen, but clear communication is key to guiding users effectively. When an API call fails, your app must react smartly to prevent crashes or vague error messages. Here's how. First, identify the error type by reviewing the status code. Log the error for troubleshooting, but safeguard sensitive data. Next, communicate a helpful message to the user and offer options like retrying or canceling. Ensure seamless handling without app disruptions. For instance, if the status is 401, refresh the token and retry the request. In case of a 500 error, inform the user to try again. Remember, handling failed requests is key to user experience. Imagine you're a user waiting for your messages to load. You make an initial request with your access token, but oh no, it's expired. The server rejects it, citing invalidity. So, you take action and refresh your token. In return, the server hands you a fresh access token. You retry your request with this new token, and voila, success. Your messages seamlessly appear, no hassle required. This entire process unfolds in the background, allowing you a smooth user experience. Just sit back and watch your messages flow in. Are you ensuring top-notch security in your API integration? Follow this vital checklist for a robust defense. Always encrypt data using HTTPS, store tokens securely, and refresh them promptly. Prioritize clearing tokens upon user logout and validate server responses diligently. Remember to handle errors gracefully and steer clear of logging sensitive data. Set optimal timeout values for network requests to fortify your system. Stay vigilant, stay secure. Let's recap the key takeaways. Utilize REST APIs with HTTP methods for seamless app-server communication. Remember, each request stands alone and lacks inherent state. Authentication tokens are crucial. Embed them in the authorization header for secure identification. Employ short-lived access tokens alongside long-lived refresh tokens for automatic access renewal. Safeguard tokens in platform-specific secure storage to prevent theft. Effective error handling is essential. Identify errors, display informative messages, implement retries, and ensure app stability. Always prioritize security and reliability in your app development. Welcome to the final slide of our presentation. Let's put your knowledge to the test with a quick quiz. Question 1. When retrieving user data from the server, which HTTP method should you use? The answer is GET. Question 2. In an iOS app, where should you securely store authentication tokens? The answer is the iOS keychain. Question 3. What should your app do when it encounters a 401 unauthorized error? Remember to try refreshing the access token using the refresh token. Now, for your practice assignment, develop a mobile app that securely logs in users, fetches their profile data, and gracefully manages token expiration. Prioritize secure token storage and robust error handling for network issues. Well done! By mastering these fundamentals of secure API integration, you're well on your way to building reliable and secure apps. Keep practicing these concepts to enhance your skills further. Remember, the key takeaway is to prioritize secure data handling in your app development journey.